Chapter 1, Section 8 is a section called New Functions from Old. This is about composition functions. Normally, when we deal with functions, we're looking at numbers. Suppose we have the function f of x equals x squared plus 4x minus 5. Then if we were to find f of 1, we would plug in a 1 everywhere we saw an x. So we would have 1 squared plus 4 times 1 minus 5. And if you add those numbers up, you get 0. Similarly, f of 3 means you'd have 3 squared plus 4 times 3 minus 5, which equals 16. If you had f of negative 2, that would be negative 2 squared plus 4 times negative 2 minus 5, which equals negative 9. This is what we normally do. When we plug in different numbers, we get a number out. Similarly, we could plug in a letter, just like we do a number. If we looked for f of h, that just means that wherever we see an x, we're going to plug in an h. So that would give us h squared plus 4h minus 5. It looks exactly the same as our original function, but instead of x, we have an h. But now let's say we plugged in an h plus 1. Well, again, wherever you see an x, you're going to write h plus 1. So that would give us h plus 1 squared plus 4 times h plus 1 minus 5. But now we want to combine like terms. So if you square out the first set of parentheses, h plus 1 squared, you'll get h squared plus 2h plus 1. Then, if you distribute that 4 to the h plus 1, you'll have 4h plus 4. Once you've squared out the first term and distributed the 4, you'll get h squared plus 2h plus 1 plus 4h plus 4 minus 5. If we combine all the like terms, there's only one term that has h squared, so we have an h squared. Then we have a 2h plus 4h, which gives us a 6h. And then you have a 1 plus 4 and a minus 5, which cancels out the constant term. So once we've combined all the like terms, we find that f of h plus 1 is h squared plus 6h. So now we can plug in numbers. We've already knew how to do that. And we can also plug in letters and see what sort of representation we get out of our function. Now let's say we have the function f of x equals 4x minus 3. Again, if we were to plug in a number, say f of 1, we would get 4 times 1 minus 3, which is 1. And again, what we're doing is we're plugging the 1 in wherever we see an x. Similarly, if we were going to do f of h, we would plug in an h wherever we see an x. So that would give us 4h minus 3. f of h plus 1 means we're going to plug in an h plus 1 wherever we see an x. So that gives us 4 times h plus 1 minus 3. You want to distribute that 4 through, which will give you 4h plus 4, and then minus 3. Combine like terms and simplify, gives us 4h plus 1. Now, no matter what the argument you put into your f function, you'll plug it in wherever you see an x. So if we plug g of x instead of h, it would look like this. f of g of x equals 4 times g of x minus 3. Again, we're just taking whatever's in the argument of f and writing it wherever we see an x. But now, if I were to tell you that g of x is a function, that's 2x squared, we could then plug that in wherever we see g of x, and our function becomes f of g of x equals 4 times g of x minus 3, which equals 4 times 2x squared minus 3. Distribute that 4 in and combine like terms, and you'll get 8x squared minus 3. This is called a composite function. When you plug one function into another, you're composing two functions to get a new function. We can compose all sorts of different types of functions in lots of different ways. And there's two ways that we can compose these. What we did last time is f of g of x. So we were taking a g of x function and plugging it into f of x. We could also do it the other way. But let's look at these two functions here and see what we get when we plug in g of x into the f of x. So again, wherever you see an x, you're going to write g of x. So we have g of x squared minus 3 times g of x plus 4. Well, we know what g of x equals. So instead of g of x, we're going to write what the function equals. So we get 5x plus 1 squared minus 3 times 5x plus 1 plus 4. Again, you want to square out any squared terms and distribute through any constants so you can combine like terms as the last step. So once you square out the first parenthesis and distribute the 3 and simplify, you'll get 25x squared minus 5x plus 2. You should try doing this on your own to make sure you remember how to do all those sorts of multiplications. Similarly, we can do g of f of x. So then we're plugging the function f into the function g. Our g function is 5x plus 1. So if you do g of f of x, you'll have 5 times f of x plus 1. Because again, you're writing f of x wherever you see an x in the g function. Then, after you've written your f of x in, you can write what f of x is. So we'll have 5 times, parentheses, x squared minus 3x plus 4, all of that, plus 1. Again, you want to distribute the constant 5 through so we can combine like terms. Once we do that, we're left with 5x squared minus 15x plus 21. Now, I want you to notice that f of g of x, the first one we did, is not the same thing as g of f of x. So order does matter here. You're always plugging the inside function into the outside function. Let's keep the same example. There's something else we can do that comes up quite frequently. Let's look at f of g of 2. Now before, we were looking at f of g of x. When there's functions with x, you should end up with a function at the end. When you have a number, you're going to end up with a number at the end. And when there's a number in the middle, you're going to start from the inside and work your way out. So the innermost term in a function f of g of 2 is g of 2. So we start by calculating that number. And that's what we usually do by just plugging the 2 into the function g. So we have 5 times 2 plus 1 is 11. So that means that f of g of 2 is the same thing as f of 11, since g of 2 equals 11. But now f of 11 is what you would normally think of f of 11. It means you're going to take the number 11 and plug it into your function f. So you'll have 11 squared minus 3 times 11 plus 4, which equals 92. So again, if you start with a number in the middle, you'll get a numerical answer. Let's look at g of f of 2. Again, we start on the inside and work our way out. First, we find f of 2, because that's the innermost function. So that means we're taking 2 and plugging it into the function f, which is x squared minus 3x plus 4. So by plugging in 2, we get 2 squared minus 3 times 2 plus 4, which will equal 2. So that means that g of f of 2 equals g of 2, because f of 2 equals 2. G of 2 means we're just taking the number 2 and plugging it into the g function. So we have 5 times 2 plus 1, which equals 11. So again, I want you to notice that f of g of 2 is not the same thing as g of f of 2. You really want to practice composing different types of functions and playing around with numbers. Once you get the hang of the order, it's not so bad, but until you try a couple on your own, they can be a little tricky. So why don't you go ahead and try some of the homework now and see if you can figure out how to do these. Also, when you get to section 1.8 of your reading, make sure you very carefully read the part that deals with graph shifting.